During Artemis 2, something inside the Orion capsule didn't just fail. It behaved in a way NASA still can't fully explain. Astronauts reported a burning smell, and not long after, attention shifted to one system that should never go wrong in space: the waste system. This wasn't just a small glitch or something you ignore. Early analysis suggests there may have been a blockage inside the system, combined with chemical reactions that don't behave the same way they do on Earth. So this wasn't just a failure, it was unpredictable. And that's what makes it serious. On Earth, systems like this rely heavily on gravity. Liquids flow down, gases rise. Everything separates naturally. But in space, none of that happens. Everything depends on controlled airflow, pressure, and precise engineering. Every movement is forced. Every reaction is managed. Which means if one part behaves differently than expected, the entire system can start to break down. One possible explanation is a partial clog, something restricting the flow inside the system. But in microgravity, a clog doesn't just block movement. It can trap gases. And when gases get trapped, pressure begins to build in ways engineers don't always predict. That pressure can lead to heat, chemical reactions, and system instability. That burning smell? It may not have been random. It could have been the result of something inside the system reacting in real time. And inside a sealed spacecraft, that's not something you can ignore. Because in space, nothing is isolated. Air is constantly recycled. The same air the crew breathes moves through every system inside the capsule. So if something goes wrong, it doesn't stay in one place. It spreads. In more serious situations, that could affect air quality, introduce harmful particles, or force astronauts to shut down part of the system entirely. And on a longer mission, that becomes a much bigger problem. Because Artemis 2 wasn't the final goal. It was a test. A mission designed to find problems before things get more dangerous. And this is where things become unclear. Even after the mission ended, NASA hasn't fully explained what caused the issue. They've confirmed that the system worked overall, but not exactly why it behaved the way it did. Was it a design limitation? A rare combination of conditions? Or something engineers didn't anticipate at all? Right now, there isn't a clear answer. And that uncertainty matters. Because future missions will go further. They'll last longer. And they'll rely on systems like this every single day. If something this small can behave unpredictably now, what happens on a mission that lasts weeks or months, where there's no quick return to Earth? Artemis 2 was a success. But success doesn't mean everything worked perfectly. It means NASA found what needs to be fixed. And sometimes, the smallest problems are the ones that matter most.